Today I am here to represent MEGAPLAST India Private Limited. Here we are manufacturing MEGAPLAST. MEGAPLAST is a company who manufactures the packaging films and using the blown film extrusion technology. Among them, the geomembrane is one of the major product which manufactured with this similar technology. This blown film is the is the process which produce the geomembrane, and this material can be today I am here going to explain how this material can be beneficial to use this water storage. Next slide please. So before going to that, what is the geomembrane? How to use this? The geomembrane is the impermeable material which is used by laying down where the barrier requirement is there. As per the ASTM standard, this material is the essential material to create the barrier when it is used in the proper method with the foundation, rock, earth, and other geotechnical engineering related material in the human made projects. And this material basically made from the polyolefin, and which is in the thickness range of several.
They have a stall outside, and I think it's very useful to visit it.
This thickness range is from several hundred microns to up to several millimeters, and these materials available in the form of roll and in the wider width of 8 meter. Next slide please. And it has a major application. Here the major role of geomembrane is a barrier in the mining, salt pans, coal, aquacultures, waste management, in the agriculture field for storing the water, in the water canals, storing the water, carrying the water, and storing it for the longer time, especially for the ponds, dams, which benefiting to use in the agriculture purpose, and landscaping, petrochemical industry, and also it's extended to use to barrier the gases, especially in the barrier gas. That is the something different product which need to have some special designing in that to use, because in the biogas there is the, it's not a liquid material, it is the gaseous material. Gaseous molecules are too small than the liquid. It needs some special designing to make this product. This material also we can use it for the gas barrier purpose.
I thought there's a guarantee also, you have some years warranty for the product.
Definitely, sir.
You could mention that. That's what I checked from your stall.
We are going to have that in the following slides here.
How many years?
Sir, it depends on atmospheric condition and the thickness of the material. Based at 40 degree, 20 degree temperature up to 1.5 millimeter, we can have around 70 years of guarantee. That calculation and analysis.
No, but 20 degrees you will not find in India.
With the different degree temperatures, we have the calculations. I am going to explain in the following slides.
About 40 degrees, 45 degrees is what the temperatures can go up to.
For that also, we have,
how many years warranty?
We can go for more than 20 years.
20 years.
Yeah.
And with a temperature variation of about 25 degrees centigrade across the day or no?
Of course. It's always there 5-10 degrees Celsius.
How many degrees variation through the day?
It's 10-15 degrees and depends on the geographical conditions.
Okay.
Yeah.
We certify these products also.
Okay.
Can you go for next
Thank
slide? Next slide, please. Yeah. Sorry. In here, how we are designing and how it's manufacturing the geomembrane using the blown film extrusion. Basically, it's made from the polyethylene material. These polyethylenes are available in the markets are in granule form. Those granule forms, once we heat above its melting temperature, it becomes a viscous molten material. That material with certain pressure we blown through extrusion, and this comes in the form of bubble at the die with a certain temperature, which below its crystallizing temperatures becomes solidifies, and that material when it's passed from the nip roll, it becomes tube. Then that tube we can collect it in the roll formats. Can you go next? When this actual bubble is looks like after when it pass from the when the polymer melt pass from the die. Next slide please. Uh, uh, Once the viscous polymer melt comes from the die, once the temperature, there is a temperature gradient from the melting to during the cooling process. When the temperature comes below its crystallization temperature, it's the nucleus forms. One that nucleus radially grows in all the direction. It forms the laminar based on the polymeric structure. It defines its density and crystallinity. That one of the parameter defines how strong is the material with the mechanical. Next slide please. This radially grows polymers can folded in the multiple folded. It creates the amorphous phase. That amorphous phase connect with each other with the multiple lamellae. It creates the density and the strength of the material. Next please. Based on this, we are manufacturing two different kinds of basically from two different kinds, from GRI GM13 and 17. GRI means that's one of the institute who certifies this material based on the base material which are using and their respective property. That is high density polyethylene and low density polyethylene, and whether the material is smooth, structured, one side or both sides depends on the end application we are recommending. From the base, both the material we are making smooth, single side smooth and both sides smooth. And individual material have their individual mechanical property as per the compliance of GM13 and 17. Next please. These are the required property. Minimum property needs to be have to make this material stable for the longer time. First is thickness, aspirity, density, melt flow. These are the most common properties to measure it. The main major and serious property which can define the integrity of the geomembrane for longer time, and those testing requires high dedicated equipment, and those testings also need for longer time. That's the test crack resistance, carbon black dispersion, carbon black content, and oxidative induction temperature after the oven aging and UV light aging. Because during the when the geomembranes are using in the atmospheric condition, there are UV light, many atmospheric conditions, those are affecting on the polyethylene material, then it start to get degrade. To avoid this, we need to have accelerated testing condition in a shorter time. That's why these testings are too longer to define this integrity. What the sir is asking, how long your geomembrane can you give the warranty? That is all, these are condition depends on these testings with different temperature. That slide also I am having the following slides. Please next slide. To perform this kind of testing, we have the standard NABL certified lab, GAI lab certified, and CE certifications. Also, we are the corporate member of IGS. We are qualifying the compliance of the M13 and 17. Next, please. Next slide, please. These are the features of higher width, and thickness range is of 0.5 to 3 millimeter, and generally it's in the black color, but if there is any something special color is required, we can, based on the request, it's possible to make. And structured material, smooth surface material. And what is the benefit of longer width? We can perform in the installation work can be faster, efficient installation, and number of joints are lesser. These are the, and liners are inspected during the process and after the process to make it better integrated and more better material. And these are the high chemical resistance, high UV resistance, and thermal resistance, and environmental crack resistance. This is the test basically required to confirm the material for the longer time duration stability. Next slide, please. What happened why this geomembrane is not polyethylene is not stable for longer time? Because of this atmospheric condition, temperature during the process there is lot of heat. The polyethylene have a tendency to degrade itself. To in the atmosphere condition, basically oxygen is the main culprit for that, and the temperature during the process and after the process as well, and it can make the reduce the mechanical strength of the material. Once the mechanical strength has been reduced, is the basic role of the geomembrane is the hydraulic barrier that going to be reduced. To avoid this, we need to define the recipe to overcome this kind of process of the oxidative degradation. And those overcoming process we are measuring it to the different test method which I already explained in the previous slide. Next slide, please.
To get rid of oxygen, do you use nitrogen while?
Of course, sir. The OIT is the measurement. First, we melt the material under the nitrogen atmosphere because it should not be degraded during the melting. Once it's melted completely, then we provide the oxygen. Under the oxygen at high temperature, how long it's stable? That is the OIT says. And this is the already proven method in the previous scientists to make the sandwich the geomembrane between the sand and keep it different temperatures in the laboratory and studies how long it's stable. And in the lab, in the picture you can see this setup has kept at the different temperatures, and after that they measured and defined the life with respect to different temperature. Next one, please. Next slide, please. This graph shows the how the material performance in terms of the to avoid this oxidative degradation, where there is the another additives which is the antioxidants. How the performance of the antioxidant, how it make the geomembrane to get rid of this oxygen, and there is a basically three methods, A, B and C. A is the antioxidant depletion, consumption of antioxidant, and B is the induction time, and C the half life of the property. Where how let's say initially something some property is at 50, when the that property comes to 25, that is 50% reduction, we can say its half life of the material has been gone. That it defines that T1, T2, T3, T4 are the after how long it the half life of that individual material remains. Next one, please. This table indicates at 20 degrees Celsius the at the last one we can say 445 years at 20 degrees Celsius. At 40 degrees Celsius it was 69 years. This one was measured from the stage A, B, C of the stage A, B, C comes from the OIT studies of the that is a differential scanning colorimetry equipment.
Why not more than 40?
Sorry?
Why not more than 40 degree temperature?
It can be.
45.
You see,
it
that's
can
why
be
I
doable,
asked
sir.
you. See, the product is that you are marketing these products in tropical countries also.
Right.
And now with global warming coming, the ambient temperatures are rising, and particularly in regions where there's stony subsoil, or those the temperatures can even hit 50.
That's true, sir. Yeah.
So if you want them to be used at 50, then your testing should be till about 55 or 60.
Extreme conditions, because it is decreasing very drastically.
That's why, you see, my first
that's
question
true.
to you was
That's
that, in fact, in the irrigation sphere, this is where a lot of micro irrigation projects have failed, because those substances have not withstood the ambient temperatures which are prevailing in field conditions. They develop leakages, etc., etc. So it's good develop these products in temperate countries, but when you are using them in tropical countries or in arid zones, you have to be particularly careful, because these are, you see, arid zones are the areas where there's water scarcity anyhow. So just a minute, we have one more speaker who's waiting. Okay,
He
okay,
is a
go ahead.
representative of
One
Samaj
question. Okay, you want to explain? Okay, go ahead.
So, sir, we are using special additives in our geomembrane.
No, please take this.
Mike.
Because I'm an old man, I can't hear.
Hello. Sir, I'm just answering your question that what is the service life designed for our geomembranes? So, sir, with all these antioxidants and special additives we add to our geomembrane, the service life of for this geomembrane is around 60 degrees. We have done stimulation test and lot of research has been done in Queen's University and in US. So the service life for 1.5 mm thick geomembrane, it's taken as 60 degrees Celsius. So under this 60 degrees Celsius, with more stringent additives and special proprietary formulations, our geomembrane can have more life.
Sir, I'm very happy that you've done that.
Yeah.
But I would like you to draw a more dynamic graph. And that is with aging, what temperature it can withstand. A product that is just manufactured can have certain qualities. But when it is 20 years old, 15 years old, so with aging, what
Yes.
happens?
Yes, sir. For example, sir, I take example of 1.5 mm thick SDP geomembrane liner used for a landfill based in USA. I mean, we have done studies for different landfills in India also. So this 1.5 geomembrane at different temperatures, like it will be susceptible to day and night temperatures, and under different leachate and chemical aggression on the liner. We have already done this.
Understood, sir, but I'm asking about the age while it is installed. Say, how will it perform after 10 years of installation, after 15 years of installation?
Yes, sir. So
And what is the life? What
right,
is the
right.
what is the valid lifespan according to these tested parameters on site for this product?
Okay, sir.
Sir.
If you consider the first day, the liner will be is designed for around 200 to 300 years of life, and after
Okay.
sir, exposure of like 5 years or 20 years, still the membrane will be having the life of around 60 years.
Okay.
So we have already done the oxidative induction.
Thank you,
time.
sir. Thank you.
Thank you, sir.
Some of the case study for this, what you asked on the life of the geomembrane, which is already on site. which
You
has
see,
been
my advice
initiated-
is that they are very useful products. You put these videos on the YouTube. So let people study these at leisure and publicize them. They're very useful products.
Thank
Thank
sir.
you very much, sir. Thank you.
Yeah. Next slide, please. There are some of the study we already have. These are the pictures of our geomembrane installed different microns of the geomembrane 0.5, 1 mm and 1.5 mm, which are installed for water storage at different sites in India. And we picked some sample after several years of installation and rechecked their properties of oxidation induction temperature and checks how much the strength is remain, how much oxidation antioxidants are consumed and how much antioxidants are available to protect the geomembrane for further life. Please next slide. See, this is one of the case study which we pick the sample after 7 years of this water storage tank, which is a 40 liter water storage for industrial water storage, and analyze their standard OIT and HP OIT is initially supplied. It was 400 and 400 respectively, and remained 87 and 45 minutes. And this material is same, which we can confirm it from the DSC based on their melting temperature and crystallization temperature. Next one, please. Until now, I have explained this the geomembrane. We can use it for the liquid storage, water storage, and during the introduction, I have explained that we are further expanding this geomembrane for the gas barrier application. That is for the 7-layer material, and we started the commercial production of the 7-layer that can be used for the gas barrier applications. In this it is the same process with 7 layer, but in the middle layer that is the specially material which can protect the gas to transfer from the other side. And next slide, please. How this geomembrane looks like? This looks like visually at a single layer, but internally it has a 7, and the outer layers are protective, and middle, the white one, is the barrier layer which avoid to transfer the gas from one side to other side. Those gas can be toxic gases like methane, oxygen, radons, water vapors. Of course, some, especially from the landfills, there are very different kinds of volatile organic compounds. Even this barrier layer can protect those gases too. So, in short, we can say that this 7-layered membrane can be used for the landfill to protect this kind of gases and collect them somewhere.
Thank you, sir. We need to close
Yes,
because
sir, just 2 slides. Sir. Next slide, please. I am going to conclude. We explore our product portfolio and the testing facility and regular quality product for our mega liner and manufacture process and the antioxidants effect and working mechanism during its service life.
thank you, sir. That was your last slide.
Oh,
Very well
okay.
illustrated.
And I'm sure this product is helpful to end user. They can select this geomembrane for their applications.
Thank you, sir.
Thank you, everyone.